Alcohol is the most widely used drug in the world, and it is also the most dangerous in terms of withdrawal. Alcohol withdrawal can be fatal, unlike heroin withdrawal, which is extremely unpleasant but rarely fatal by itself. This fact, which surprises most people, illustrates why understanding drug classifications and mechanisms is not just academic. Knowing how different drugs work at the neurological level is essential knowledge for understanding both their therapeutic uses and their dangers. Central nervous system depressants reduce neural activity by enhancing the effects of GABA, the brain's primary inhibitory neurotransmitter, and by suppressing glutamate, the primary excitatory neurotransmitter. Alcohol works through multiple mechanisms, but primarily enhances GABA and inhibits NMDA glutamate receptors. Barbiturates and benzodiazepines bind directly to GABA receptors to amplify their effect. The symptoms of depressant intoxication, relaxation, slurred speech, impaired coordination, and judgment reflect widespread neural suppression. The danger of withdrawal from chronic depressant use is rebound hyperexcitation, seizures, delirium, and potentially death. Stimulants increase central nervous system activity, producing elevated mood, increased alertness, reduced fatigue, and heightened arousal. They work primarily by increasing the availability of dopamine and norepinephrine in synapses, either by promoting their release, blocking their reuptake, or inhibiting their breakdown. Caffeine works differently, blocking adenosine receptors to prevent the fatigue signal. Cocaine blocks the reuptake of dopamine, norepinephrine, and serotonin simultaneously. Amphetamines both block reuptake and stimulate release of catecholamines. The intense euphoria of cocaine and methamphetamine reflects massive dopamine flooding of the reward circuit. Opioids bind to the brain's endogenous opioid receptors, the same receptors that respond to the body's natural pain relief chemicals, endorphins, and enkephalins. They produce powerful analgesia by suppressing pain signal transmission in the spinal cord and brain, and euphoria by activating opioid receptors in the reward circuit. At high doses, opioids also suppress the respiratory drive, causing the respiratory depression that is the primary mechanism of opioid overdose death. Naloxone reverses overdose by competitively displacing opioids from their receptors and restoring breathing. Hallucinogens, also called psychedelics, profoundly distort perception, thought, and emotion, often producing vivid sensory experiences that have no external source. LSD and psilocybin, the active compound in magic mushrooms, are serotonin 2A receptor agonists. They mimic serotonin at a receptor subtype particularly concentrated in the cerebral cortex. This activation disrupts the normal filtering of sensory information, flooding the cortex with perceptual data that bypasses normal gating. Cannabis, technically a cannabinoid, acts on endocannabinoid receptors to produce a varied set of effects including perceptual distortion, altered time sense, and relaxation. Tolerance develops when the brain adapts to the chronic presence of a drug by reducing its own sensitivity to it, downregulating receptors, or compensating in other ways. As tolerance develops, the same dose produces less effect, and larger doses are required to achieve the original response. Tolerance is one of the key features that drives escalating drug use. Importantly, tolerance is often context-specific. A dose that an addict can tolerate in familiar surroundings may be fatal in an unfamiliar environment because the body's conditioned preparatory responses do not activate without the usual context cues. Physical dependence exists when the body has adapted to a drug's presence to such an extent that its abrupt removal produces a withdrawal syndrome, a set of symptoms opposite to the drug's effects. Alcohol depresses the CNS, so alcohol withdrawal produces CNS hyperexcitation, tremors, anxiety, hallucinations, and potentially fatal seizures. Opioid withdrawal produces pain, anxiety, nausea, and diarrhea, extremely unpleasant but rarely fatal. Physical dependence can develop without addiction and occurs with many legitimate medications, including antidepressants, beta blockers, and corticosteroids. Addiction, now formally called substance use disorder, is characterized by compulsive seeking and use of a substance despite significant negative consequences. It is not simply physical dependence. Many people are physically dependent on medications without being addicted, and people can be addicted to behaviors like gambling without clear physical dependence. Addiction involves profound changes in the prefrontal cortex, reducing the capacity for inhibitory control, and in the dopamine reward system, producing a state where drug cues become overwhelmingly salient, while natural rewards become relatively uninteresting. The mesolimbic dopamine pathway runs from the ventral tegmental area in the midbrain to the nucleus accumbens in the forebrain. This is the brain's primary reward circuit. When you experience something rewarding, dopamine is released in the nucleus accumbens, producing the sensation of pleasure and reinforcing the behavior that produced it. Addictive drugs hijack this circuit by producing dopamine releases far exceeding natural rewards. Cocaine can cause nucleus accumbens dopamine levels 10 times higher than sex or food. Over time, the circuit recalibrates around drug-level stimulation, making natural rewards feel flat and unrewarding. Psychologist Timothy Leary emphasized that the subjective experience of psychoactive drugs is powerfully shaped by the user's current mindset, expectations, and intentions, and setting, the physical and social environment in which the drug is taken. The same dose of psilocybin can produce a transcendent mystical experience in a supportive therapeutic context or a paranoid nightmare in a chaotic social setting. This context dependence is why modern psychedelic-assisted therapy protocols invest heavily in therapeutic context preparation. The drug is not the therapy. The drug plus the context is the therapy. Psychoactive drugs are not morally simple substances. They are chemicals that interact with specific neurological systems in ways determined by the drug, the dose, the person, and the context. Understanding their mechanisms does not justify use, but it is essential for evaluating policy, treating addiction, and developing the next generation of psychiatric medications, many of which may be derived from currently controlled substances.